Hi everyone and welcome in my channel. In this tutorial video we will talk about sensitization step. So when a patient received foreign blood, how it may sensitize and produce antibody against a foreign antigen. And also we will talk about hemolytic transfusion reaction. We will talk about intravascular hemolysis. Also we will talk about extravascular hemolysis. Sensitization is considered one of transfusion complications that may happen in recipient. So a patient may sensitized and his immune system triggered by foreign antigen come from a donor and produce antibody against the foreign antigen. These antibody will lead to remove the RBC from the circulation. So it's either lyses the RBC inside blood vessels, or it may remove it later from the blood circulation, and we will explain this when we talk about extravascular hemolysis. There are many RBC antigens, and today there are more than 350 RBC antigen found, and but luckily not all of them are highly immunogenic. So not all of them, in case of a compatibility, may trigger the immune system and produce antibody against these antigen. Some of the antigen are we can call them highly immunogenic antigens, such as the antigen, for example, but some of them is lower immunogenic. For example, we Dumbrock antigen. So plasma cell of the patient, as we explained in the previous video, may produce antibody against the foreign antigen, and we call this antibody allo antibodies. There are two types. Allo antibody may be considered as clinically significant antibody when these antibody are able to reduce the lifespan of the RBC from 120 days up to several minutes or hours. Other type of allo antibody, we call them non-clinically significant antibody. So these antibodies don't have the same effect as the clinically significant one. However, they still cause complication in pre-transfusion tests. So when these non-clinically significant antibody present in patient, it may complicate the cross-matching process. And again, we will talk about this later in future video. Let's take now an example and explain how sensitization process happen. So, for example, if we have a patient, let's call this patient Nasser. Nasser is D negative. That means Nasser don't have the antigen on his RBC blood. So when a donor, on the positive donor, for example, let's call him Fahad, is D positive. So the RBC of Fahad contain the D protein. When Nasser received this blood, the immune system may triggered by presence of these foreign antigen and produce antibody against this particular antigen. So in first time exposure, the immune system of Nasser will take time to produce anti-D, so we don't expect hemolytic transfusion reaction happen in first time exposure. So let's see now in second exposure what will happen. We have Nasser here. Nasser, as we said, is D negative, so he doesn't have the antigen. And now there are anti-D in his circulation. So when Nasser receives blood again from donor who have the antigen, the anti-D will the anti-D now will bind to the donor RBC, leading to remove this blood from Nasser circulation. In the previous video, we explained how immune system produce antibody in first and second exposure. Hemolytic transfusion reaction, as we said before, can be divided into two types. The intravascular hemolysis. So the hemolysis of the RBC happen inside the blood vessels. And the other type is the extravascular hemolysis. So the RBC is removed from the circulation in the secondary lymphoid organs, such as and mainly in spleen and sometimes in liver. Let's now talk about intravascular hemolysis. But before we start and explain the intravascular hemolysis, we have to understand the role of complement and what is complement proteins can do. Complement system is a group of proteins present in active form in the plasma. They have roles in antigen clearance and cell lysis. Complement proteins can be activated by two different pathways, the classical pathway and alternative pathway. We will focus on this one. So in this video, we will see together how complement proteins is activated by the classical pathway and form the membrane attack complex at the end. When antibody bind to antigen, this will activate the complement, the C1q, C1r, C1s complex. This complex will split C4 and C2 proteins into two parts. The C4b and C2a fragments joins to form C3 convertase. The C3 convertase splits the C3 into C3a and C3b. So the C3 convertase joins with C3b to form C5 convertase, which have the ability to split the C5. The membrane attack complex formed from C5 to C9 proteins. This will leading to produce holes in the cell membrane, leading to osmotic lysis. Water and small molecules will come inside the pores, leading to lysis of the RBC. So again, in the intravascular hemolysis, as we said, the binding of antibody to the antigen will lead to activated complement proteins, which will form pores on the red cell membrane, leading to lysis of the RBC. So the hemoglobin will be free in the circulation, leading to harm organs such as kidney. Extravascular hemolysis is a quite different story. The affected RBC cells are removed from the circulation in spleen. So when RBC coated with antibody or complement proteins, such as C3b, we will call this sensitized cell. So when the sensitized cells reach the spleen, macrophages there have receptors can recognize these sensitized cells and promote phagocytosis. So the destruction of RBC or the removing of RBC will be in the spleen rather than inside intravascular hemolysis, such as and the other mechanism. So in this tutorial video, we talk about the sensitization process, how a patient becomes sensitized, and we explain the intravascular hemolysis and talk about complement cascade. Also, we talk about extravascular hemolysis. I put useful video link in the description box explain the complement system in a good details. So thank you for watching and see you in the next video.